Okay, please go ahead and start. You have 20 minutes, so plenty of time. So take your time. Please present yourself first and then go ahead with your presentation.
Okay, thank you, ma'am. Good evening, all. Myself, Sindhya Nambiar, research scholar from Department of Computer Science, Kochi University of Science and Technology, India. My paper is Attention-Based Abstractive Summarization of Malayalam Document. This is the outline of the paper. Introduction, objective, proposed system, data pre-processing, sequence-to-sequence model, then attention model, experimental result, conclusion, then references. First, introduction. Text summarization is to condense a large amount of information into a concise form by selecting the most important information, discarding the redundant information. Summarizing manually is a very difficult task. It involves reading and understanding, and also it's a time-consuming task. Based on the summarization approaches, we have two types of summarization: extractive summarization and abstractive summarization. Extractive summarization is to identify and extract important sentences in the document and combine them to form the summary. Abstractive summarization is to identify the salient content in the document and present it in the concise form. And this paper is focused on in my native language, that is Malayalam. Malayalam is a morphologically rich language. Vocabulary of Malayalam language is borrowed from other classical languages, mainly from Sanskrit and Tamil. Two characteristics make Malayalam unique from other languages. It does not have predicate agreement between subject or object and verb for gender, number, and person, and is having prevalent usage of copulars and utterances. The objective is to develop attention-based model for abstractive summarization for Malayalam document and evaluate and compare the model with pre-trained sequence-to-sequence model using Roche metrics. This is the proposed architecture. Data set is generated from news repository of BBC, that is news repository and summary from BBC, and translated those news to Malayalam language using Google Translate. Next is the data pre-processing state, and the pre-processed data is split into training set and testing set. And this using attention-based sequence-to-sequence learning, this training set is trained and generate an attention model. And this testing set is fed into this attention model will get a summary. As my pre-work is a sequence-to-sequence model, and the same testing set is fed into the pre-trained sequence-to-sequence model will get another summary and evaluate both summary using roll score and compare those summaries. The first phase is data pre-processing. Pre-processing includes tokenization and stemming. Tokenization is the process of splitting up a sentences into small pieces known as tokens or words. And this is the output of, it's a Malayalam sentence, that is, idu oru sthalamanu. It's a Malayalam sentence. And after tokenization, this sentence is split into each token. And the next process is stemming. Stemming is the process by which each word in the document is taken and its root word is identified, removing its suffixes. So this is also a Malayalam word, means marathil. And after stemming, the suffixes of this term is removed and will get maram. Sequence to sequence model. Sequence to sequence model, we have two phases, that is encoder step and decoder step. In the encoder step, a model converts an input sequence into a fixed representation. And in the decoder step, a language model is trained on both the output sequence as well as the fixed representation from the encoder. This is the architecture of sequence to sequence model. Both these encoder decoder model architecture consists of two LSTM networks. One is encoder LSTM networks and second one is the decoder LSTM networks. Input to the encoder LSTM is the source sentences, and input to the decoder LSTM is the abstract form of the sentence. This is the abstract form of the source sentence, and this one is the input sentences. After this encoder, we got encoded vector, and this also fed into this decoder. We'll get a summary. A type of encoder-decoder model is using recurrent neural network. It's a class of artificial neural networks in which they use their internal state to process variable length sequences. Source sentence X equal to, we split the source sentence as words and is represented as X1, X2 up to N, and transforms those sentences to its hidden states, that is HE1, HE2 up to HEN. The decoder accepts context input as in the form of hidden states and then produces a summary Y. Xi is the one-hot representation of the words in the source article, and Yj is the same of the summary. And the decoder accepts two inputs. One is the internal state from the encoder, which is also known as the thought vectors. And second one is the input sentence, which is fed into the decoder, which is the target sentence with the start of sentence token appended at the start and the end of sentence token appended at the end. At each decoding step, update the hidden state condition on the previous hidden states and input tokens. Since only the hidden states are passed, the cell states in the input and output of LSTM are not explicitly expressed. Next, the attention model. The basic encoder-decoder model failed to scale up. The main bottleneck is the fixed size thought vector. It's not able to capture all the relevant information of the input sequence as the model size up. At each generation step, only a part of the input is relevant. Attention mechanism helps the model decide which part of the input encoding to focus on at each generation step to generate novel words. At each step, the decoder outputs hidden state from which we generate the output. This is the architecture of attention model. Here we have the same encoder LSTM encoder LSTM and decoder LSTM, but in between that we have an attention layer. Here we are using a single attention layer. For this attention layer, it splits into two: alignment score, attention weight, and context vector. Attention layer consists of alignment score, attention weight, and context vector. The alignment score maps how well the input around the position J and the output at position I match. The score is based on the previous decoder's hidden state just before predicting the target word and the hidden state of the input sentence. The alignment score calculation, this is the calculation of alignment score by using the dot product of the previous hidden state and the coming hidden state. The alignment score calculation needs the output from the decoder from the previous out time step. The function A is called the alignment model and is implemented as a feed-forward neural network. The alignment score quantifies the amount of attention the decoder will place on each of the encoder output when producing the next output. And the normalization permits them to treat it like probabilities, indicating the chances of each encoded input time step being relevant to the current output time step. These normalized are also called attention weights. For calculating this attention weight, we are using softmax, just softmaxing the alignment score. Next thing is the context vector. The new attended context vector is calculated by multiplying each annotation with the attention weight from which the current output time step can be decoded. The context vector is a weighted sum of the hidden state and normalized aligned score. Decoding is performed as per the encoder-decoder model. As in the sequence-to-sequence encoder-decoder model, here also decoding is same as. The context vector will be concatenated with the previous decoder output. It is then fed into the decoder RNN cell to produce a new hidden state. The output of the decoder is referred to as a hidden state. The experimental set, here we are using data set, and it was generated by translating the news repository and its summary from BBC into Malayalam language. For translating, here using Google Translator. Then pairs of a paragraph text and its abstract form forms the data set. This is the summary output. Here is the source paragraph, and this is the target summary required. And after sequence to sequence model, model generated this summary, and the attention models generated the second one. This is the Roach score result in the sequence to sequence model. Roach 1, Roach 2, and Rogel. These are the results with batch size 64. When modifying the batch size up to 128, the result comes like this. And the conclusion, the proposed system discovers various inherent semantic and compositional aspects of the document independent features. The The model predict an understandable summary with reducing the training loss for documents. And these are the references I referred. Thank you. Any questions?
Thank you very much. Any questions? Yes, Dr. Hassanin, please go ahead.
Yes, thank you, Dr. Samha, and thank you, the presenter, that we received one of the comment that's related to at the level of to generate your data. How to know this is redundant data or some repetition happened within the input to receive? How to know this is redundant or not, at the level of encoder or at the level of decoder?
Pardon, sir, I didn't get you. Can you repeat?
You have some repetition. Sorry. If you have double of your the input that include double of file, double of document, same document, redundant data. How to mention about the attention for this redundancy?
Yeah.
So let me phrase the question. Dr. Hassanin is asking how do you handle? Please correct me if I didn't get it right, Dr. Hassanin. How are you handling redundant data and ensuring that it doesn't affect your model? Is this the question, Dr. Hassanin?
Yes, of course.
Attention model focus on the redundant data, the more important keywords from the abstract sentences.
But I think Dr. Hassanin, what Dr. Hassanin meant, if you have duplicates, it's not just redundant, it's you have the document repeated more than once. You don't want to actually, it's going to bias the model.
This is a biased model, yes.
So what do you do in order to avoid that?
At least to take into your consideration within your future work. This is the point. No problem.
Sorry, about the data set. Do you want to know about the data set?
Some of the data set you had, how to be sure that this data set is not include any redundancy, no repetition between them.
Oh, data set. I translated those data set and verified with manually verified data set. It's manually verified, and the summary also verified from one doctorate person in my language, Malayalam language.
Okay, no problem. Go ahead, Dr. Samha.
I know I don't have anything to add. Thank you, Dr. Hassanin. Are there any more questions? Okay.
Dr. Samha, we can look at the new scenario for the adversarial document within machine translation within your conference in future, inshallah.
Yes.
Adversarial data.
Yes.
This is the point. How to be sure the security issue.
Yes.
Look at the scenario, please, inshallah. Thank you.
We welcome. This is a very important topic, and actually, one of my students is working on this in the context of no, it was speech, but yes, absolutely, Dr. Hassanin. Okay, going back to the presentation, I'd like to ask another question. The comparison that you have presented was all on your data set. Does this mean that there are no other data sets for summarization in the Malayan language?
No, there's no data set available in Malayalam language. So I got the English data set. There are many data set available in English language. So I took that data set and translated those data set into Malayalam.
Okay, so you translated both the articles themselves and the summary.
Abstract form, yeah, the source and also its abstract. I translated both and verified with one doctorate person of one of my friend, and then I applied the data set into here.
Okay, so your one of the contributions is not just the technique, but also the data set which can be used in the future by anyone else, I assume.
Okay.
Yeah.
Yeah.
Is this data set available for other researchers? Have you provided a link in the paper or something so that?
Not now. No, not now, ma'am. After completing my research work, I will openly
And
make it open.
please forgive me if I've missed this, but how big was this data set? How many articles?
Now it's only around 5,000, 5,546 pairs.
Okay. Now,
I'm trying to improve my increase my data set.
oh, so you are going to
It's
expand.
manually
Okay.
done. No, that's
Okay, but I think because Malayan is
Malayalam.
I'm sorry if I pronounce it wrong.
Yeah,
Malayalam, okay, is under resourced. So it's I think that if you provide this data set sometime soon, this would be a very useful tool for other people doing work in your area. So.
sure, ma'am. Sure.
I would avail it as soon as possible. I mean, that's just advice, but of course, it's completely up to you. But it's always nice if you have a resource to share it with others, especially in under-resourced languages.
Okay, sure, ma'am.
Okay, thank
Okay,
you very much for your presentation.
thank you, ma'am.
And I think if you can stop sharing your screen,
Sure, thank you, ma'am.
you're very welcome. The next presenter can, if I think I'll yes, hello. You're muted. You- Uh, you're Aladdin, I think. I assume you are muted for some reason. I am going to ask you to unmute.
Hello, can you hear me now?
Yes, yes.
Yeah, my name is Aladdin Benayed.
Ala, Aladdin.
Aladdin.
Aladdin. Okay. If you can, we still have 3 minutes, but we can
Okay.
use the time for if you can just start sharing so that at exactly 2:20 we can 2:20 GMT we can start. That would
Okay.
okay. Thank you very much.
Okay.